All right. You can pass your test up too. 1997, and just put it right here. 1997, AB1. This is the last free response in the free response packet 2. It says a particle moves along the x-axis. So you got this little particle that's dancing along a horizontal axis. So it's just moving here and here and here and here, and it's just going back and forth. That's all it can do is go left and right. Now this equation talks about and describes the motion of that particle, and they actually give us the velocity at any time greater than or equal to 0. So pay attention to that. Do we have to worry about negative time values? So when we do any sign analyses, we can start it at 0. Given by d of t is equal to 3t squared minus 2t minus 1. The position for x of t is 5 when t equals 2. And I meant to give out a hint last night, but I've just been so preoccupied with my wife, and I forgot I had taxes today, so me and my wife it was crazy at the house last night. Good, all our tax stuff together. But anyways, I give you v of t. Part A, write a polynomial expression. Obviously, it's going to be a polynomial because v of t is t squared. What do you think x of t is going to be? It has to be t cubed. Think about a derivative.
Oh, yeah.
Simple power rule always reduces the degree by what? 1. Now I want you to think about this logically. I want to find a polynomial expression for the position. We have what? So I want to go up a derivative. So I have velocity. Velocity is 3t squared minus 2t minus 1, and I want to go up a derivative. Right now you're about to learn simple power rule. For not what's called a derivative, it has a name. It's called an antiderivative. Are you ready? You're getting this before everybody. It's called an antiderivative. Now I want you to think about it. It's the only antiderivative rule. We only learn a few antiderivative rules. We learn simple power rule. We learn all our derivative rules backwards for tangent and cotangent and secant and cosecant and all those. And then we have a chain rule, and that's it for antiderivatives. That's the only rules we learn. There's no product rules. There's no such thing. Well, there is. It's called the integration by parts, but you don't do that unless you do Calc 2 and Calc 3. All right, so I want you to think about it a second. In other words, an antiderivative is thinking about the function who gave you this for a derivative. So you're trying to figure out what's the function whose derivative is this. You're trying to figure out position. What just happened? You're trying to figure out position. In other words, you're trying to figure out the function whose derivative is this. Well, we know velocity is the derivative of position. So I want to go backwards. I want to go backwards through a derivative. Now think about how you got a derivative. What did you do when you did a polynomial? Use simple power rule, right? So what did you do? You multiply by the exponent and you subtracted 1. Say it with me. What's simple power rule? You did what? Multiply by the exponent and then did what? We got to walk. So if you multiply by the exponent, that's step 1, and then subtracted the exponent, that's step 2. I got to retrace my steps. So what do I want to do first?
Add an exponent.
You want to add 1 back, and then divide by the new exponent. Because you're walking, it's like retracing your steps. Step 1, simple power rule when you take a derivative, is multiply by the exponent. That's step 1. And then subtract 1 from the exponent. So simple power rule backwards would be add 1 back to the exponent and divide by the new exponent. Let's try. Add 1 to the exponent, be t to the what? 3rd. Divide by the new exponent. What's 3 divided by 3? Now, just look at that. Does that even make sense? Is the derivative of t cubed 3t squared? Yeah, it's not bad, is it? So that's called an antiderivative. Everybody say it. Antiderivative. It's the antidote to the derivative. Okay? T's negative 2t. Add 1 back. T squared. Divide by the new exponent. Does that make sense? Is the derivative of negative t squared negative 2t? All right, what about a constant? What would you have got this from? Minus t. Now, here's the thing. Here's the kicker. Here's the kicker. You don't know if there was a constant, do you? Because what's the derivative of a constant? Do you know if there was a constant or not? So when you do an antiderivative, listen to me. When you do an antiderivative, there's always a plus c. Because you don't know if there was a constant or not. Could be 0. It's still a constant. The problem is you don't know what it is. There's ambiguity. Okay? You don't know there's a constant. So when you do an antiderivative, there's always a what? Plus c. Everybody say it. Plus c. Okay, I'll tell you what that means later. It's called the constant of integration. But for now, just know there's some constant. We don't know what it is. That if you took the derivative of it, it gets 0. And since there's nothing there, I don't know what it was. I can't determine what it was. But, by the way, if you did this, you would have gotten a point. Okay? The second point comes from using this because what they do is they give you a point on the position graph. And why do you think that's helpful? So they're saying the position is 5 when t equals 2. In other words, x of 2 equals 5. How is that going to be helpful? Because you can figure out the constant now. What would you do? Plug in 2 for t, so I'm going to have 2 to the third. Stop it, board. I'm going to have 2 to the third. Come on. Minus 2 squared minus 2 plus c. And what does this have to equal? 5. Okay? You with me? You're not looking at your wedge project? All right, so we're going to have 8 minus 4. 4 minus 2. So we're going to have, if I come up here, we're going to have 5 equals 2 plus c. So what's c equal? 3. Isn't that awesome? We now have the position function. X of t, or yeah, x of t. They didn't use s. By the way, s or x is acceptable for position. S or x. Sometimes they use y. If they say specifically a particle moves along the x-axis, they'll do x of t for position. If they say the particle moves along the y-axis, they'll do y of t. If they don't tell you what axis they're on, they'll use s of t. Okay? X of t is equal to, what was the equation? T cubed minus t squared minus t plus what? 3. There you go. There's your position equation. And that's like, for what values from 0 to 3 is the particle's instantaneous velocity the same as its average velocity on the closed interval from 0 to 3? Now, you read this problem right away, you're like, I don't know what they're asking. Golly, that's a lot. Let me read it again. For what values from 0 to 3 is the particle's instantaneous velocity the same as its average velocity? What is the instantaneous velocity, first of all? Do we know the instantaneous velocity? Yeah, you got the formula right here. That's instantaneous velocity. The velocity at any time. Not an average time, but at any time. That's what defines it. V of t is instantaneous velocity. So 3t squared minus 2t minus 1, we have that. So I want to know from 0 to 3, when is the particle's instantaneous velocity the same as the average velocity on the closed interval from 0 to 3? Now come on, you guys know how to do average velocity. Average velocity is just 9th grade slope. It would be the position at 3 minus the position at 0 over 3 minus 0. Remember, average velocity is displacement, change in position over change in time. Why do you think they had you do part A first? Because you can't do part B without part A. You needed the position equation. So can I find the position at 3? Yeah, let's do it. 3 cubed. 27 minus 9. 18. 18 minus 16. 16 plus 3. 19. So that'll be 19 minus, what's s of 0?
No, wrong.
3. What's wrong? Is that wrong?
Yeah, isn't it 18?
Okay, wait. 3 squared is 27. 27 minus 9 is 18. 18 minus 3.
It's 15.
15 plus 3. 18. No, I messed up. Okay, 18 minus 3. Is that better? So, S of 3 was 18. S of 0 is obviously what? 3. That one's easy because we found C earlier. All right, and then that'd be 3. So this is going to be 18 minus 3 is what? 15. 15 divided by 3. 5. Now, you would have gotten a point for that. Now, what do we do with that? we want to know when the instantaneous velocity is equal to the average velocity. So I take instantaneous velocity and set it equal to, so I'd set this equal to this and say they're equal. So it'd be 3t, here we go, 3t squared minus 2t minus 1 equals 5. What do you do? Please, no. Always zero it out. Okay, this is science class, zero out the dumb scale. Okay, because you can't weigh anything unless the scale's zeroed out. All right, 3t squared minus 2t minus 6 equals 0. What can I factor? Can I factor anything out? No, so let's see if it factors. All right, let me see. I'd Morse method it up. Negative 18 factors a negative 18. I went 3 times negative 6. Factors a negative 18. That'll add up to give you negative 2. Don't think so. Guess what I'm using then? Quadratic formula. So, quadratic formula. T will equal opposite of 2 plus or minus the square root of 4 minus 4 times 3 times negative 6 all over what? 6. So we'll get 2 plus or minus the square. That's going to be, is that 4 squared?
It's 2 squared.
Oh yeah, it's 2 squared. B squared. I went b squared minus 4ac. So it's going to be 4 minus, that'll be plus, won't it?
Yeah, we plus.
That's 24 times 3. What's 24 times 3? 72, 76. Somebody said it. Square root of 76 all over 6. All right, I need 2 decimals. I need 2 plus square root of 76 over 6. Somebody quick. Well,
Just like terrific.
is this? Are we done though? Did we answer the question?
Plus it's like
3 point what? What's the negative one? So 2 plus square root of 76 over 6 would be 3.45. What's 2 minus the square root of 76 over 0.45? 0.547. 0.547. So those are 2 answers. By the way, this would be acceptable too. 2 plus or minus the square root of 76 over 6, because we did solve for the times, right? So there's 2 times where the instantaneous velocity is equal to the average velocity. There's 2 times. All right, and then final question. Find the total distance traveled by the particle from 0 to 3. How do we do that? I want to find total distance from 0 to 3. Figure out where to change the direction first. So I need to take v of t, set it equal to 0. So I'm going to take 3t squared minus 2t minus 1, set it equal to 0. Does this one factor?
Yes.
I think this one factors. This will go 3t and t. It's going to have to be 1 and 1. It'd be plus 1 minus 1. So I have t equals negative 1/3 and t equals what? Which one do I not really need to consider in my sign analysis? Why?
Greater than 0.
It's greater than or equal to 0, so you go 0 to 1, 1 to infinity. Do your sign analysis for velocity. Watch. Let me say something before I let you guys go. We've got about a minute. When you do your sign analysis, always test. Listen, this is huge, huge. Always test not the original equation for velocity, but the factored equation. It's so much easier. Because watch how easy it is. I can pick 2. 2 is going to make this what? Negative or positive? Just real quick. Positive. 2 is going to make this what? What's a positive times a positive? How easy that is. Now, 1/2. 1/2 is going to make this what? Positive. 1/2 is going to make this what? Positive times a negative? Negative. So what you would do is you would do the displacement. It changes direction at 1. So just to finish it, total distance, I won't work it out, but it'd be s of 0 minus s of 1 plus s of 1 minus s of 3. And then that would give you your total distance. All right, see you tomorrow. Homework, so Moodle.